Yo, 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 yo! What's up, what's up, what's up, everybody? Welcome back. Today, we are working on our neural network to scan barcodes again. Today's topic is trying to work a little bit on our like full flow validation. So kind of last night, I was been training. I was training some experiments, and we got to a point where we have like a pretty decent scanner on perfect data that we've generated, right? So this is not really representative of like the real world very well, but we generate a bunch of images. We predict in a convolutional neural network how like what the value of each bar is. I suspect that this is an easier problem than trying to predict the code directly. It does mean that we need data of labeled bars in a barcode, but that's, but that versus barcode is like equivalent in some way. But yeah, so we are predicting each of the bars. And we finally are at a point now, if you look at this like green bar, as I scroll through these like 40 images, where like almost every single one is like fully correct on our training data, right? So we are not evaluating, except for this one bar was wrong on image 16, right? But this is not real data. And also, this is not even in the context that we will actually run this thing in, right? So our kind of like full application flow is going to be, we take this like high res-ish image, right? And we kind of downsample it to something low res, and we kind of extract a bounding box of where we think the barcode is at low res. I think that this is using like a slightly worse network than the one I have right now, but like it's fine, right? So what you'll notice here is that like it's not a perfect box, right? We like resample the high res image like into that box, which results in this like skewed fucking image that's like way too tall. There's improvements to make here. But it like we end up with this thing, and then we run our scanner on this thing, and we output. We have to run it both upside down and right side up, because although I would think that those are the same, they do not produce the same results. And running like when it is oriented the way that we expect to scan it, it produces the right results. So there's something there as well that we have to fix in training. But for now, this is what we have to do. And so the question is in this context, not in the context of perfect images that we're training on, but in the context of extracting and then running it, how good are we doing? Because like that's a different question, and that if that's a like has a significant difference between that and our training, then we know that we need to like update our training to match this behavior in some way, right? This also, if we manage to get some sort of nice visualization of this, then we can also just plug this in to, these pictures I took of a can of mayo. We can like plug this data set into the same flow and just say that every single guy is expected to have the same code, and we can kind of see how far we are from like working on a reasonable, realistic piece of data, right? And so that's the plan, is to try to do those two things. So I think the plan is to take this like scanner app that we have that's like, what the fuck? Why is it rebuilding? Oh, because I'm in a different folder, that's why. So the plan is to like take this scanner app and basically like upgrade this UI into something where we could look at an overview, right? So this guy already is looking at many images. I want to like take those many images and say, show me which ones were good, show me which ones were bad, and I want to like click on that and investigate further. That's kind of the plan. That's the plan. So first thing to do, add an overview, right? This thing, instead of showing like one image at a time, this is like an okay debug view, right? It lets us see what each component of the network did, kind of. It shows us like what we extracted, basically. But this should be kind of like the tier 2 view. The tier 1 view should be, show me all of the fucking things that we did, right? So I guess that means that somewhere in our UI, there's a couple ways we could do this. You could show like all of the images in like a thumbnail view with kind of like red highlights around the bad ones, or the ones that did not get a perfect score. I don't really think that's great. Because like in reality, I don't really care what the image looks like unless it was wrong, right? So maybe something that looks a little bit more like this, where we have like a list, maybe like something with like better information density is kind of what we want, right? So maybe something where we have like a list that's scrollable, right? And here we have just like image name, and then we say like correctness count, like 0, like this would be like 0 out of 95. How many of the bars did we get right? And then maybe we sort by this field. And then when I click on this, it brings us into like a investigation view. And then we need to be able to get out of that investigation view. So maybe there's just like a back button in the top left or something that lets us do that. Yeah, sure. Something like that. We'll figure it out. So let's start with the list. We need to look at our GUI framework and see what options do we have? What do we have in there? Widget factory. What types of widgets do we have? Label, button, text box, selectable list. That's close. Close to what we want. Color picker, drag float, drag. Do we have a thing that can just like, I think there might be a way, make interactable sounds nice. We could kind of just have like a list that we lay out however we want, and each item in the list we wrap with this like make interactable thing, and we say on click you like clicked the item. That seems kind of reasonable. So then we could just have a bunch of like interactable labels. Yeah, okay. Can we could do something like analogous to like a flexbox layout. So maybe we want like in here, like what do I want? I probably want with like the number is nice, but also kind of like highlighting this whole section according to like how bad it is might be nice. Might be. So maybe we have like a cell in here where we have like the image ID, and then we like draw like a backdrop on the whole clickable area that is like red to green for like good to bad or something. Let's just start with the text and figure it out from there. Maybe we'll be okay with it. Okay. So let's start there. So our GUI, we're gonna have some like root renderer widgets here. Build UI. So this guy, instead of returning whatever the fuck he's returning right now, I guess we want him to make a list of things. So it's literally just for each image, tell me how good we are. So we kind of want to build this UI, I guess, like after we've run the networks. So this kind of comes all the way down to the bottom. And in here, we have, how do we do this? How do we do these like metric calculations in our training loop? I guess is the question we need to ask ourselves. Somewhere in here, we generate stats for how many were correct. Okay, I see. We just like fucking manually run that shit. Which is fine. We can do that here as well. We maybe want to get a little bit better. We maybe want to like factor that logic out, but for now, we'll just rewrite it. So here we have predicted codes and predicted codes flipped. And this is, I think, for all images. So I think we want to go like 0 to however many images we have. Where does that come from? Where does that information come from? Make bars, maybe? We have batch size here. Okay. So for each image ID, we are going to look at predicted codes CPU from, I guess it's like output start is image ID times 95, because there's 95 bars per barcode. And output end is going to be output end is output start plus 95 bar like output len. Here we go. Boom. Output len. Bang, bang, boom. Okay. And I guess we want to know in this image, on either flipped or unflipped, did any of these match expected? So do we have expected anywhere? We have, when we have make bars, one of the things that comes out of this is labels for training. It's like bars. So do we have bars anywhere in here? No. We are not using that anywhere. So we have bar. So I guess we could say expected CPU is, let's yoink that shit off the GPU real quick. So we're looking at bars like this. And I guess we are trying to check that expected CPU we go like for output start to output end. Maybe this is from 0 to output len, to be honest. I think that makes more sense. We look at correct bars. We count how many there are, right? Probably. Zapoid, thank you for the prime. Much appreciated. Flipped bars. And for each of these, we just say like, predicted true is that this thing is greater than 0.5. We have predicted flipped true is just the same thing, but from the flipped side. And then we have expected true is the same thing here. We have like expected CPU from output start plus I is greater than 0.5. All of these are supposed to be plus I. And then we say like if predicted true is equal to expected true, correct bars plus equals 1. And then we do the same for flipped. And then that means that here, we can check if either of these are full. Or I guess we don't really have to do that, right? We just push this, we take the bigger of the two. And we put them in some list, right? So we have like image. I guess somewhere we need to like have something that we pass to like UI building. So like image info. And I guess this is literally just like like this. Right now it's literally just like it's like correct bars. It's really just this, right? For now. There might be, oh, we have the name as well, right? I'm doing this as a string, even though it could be an integer, because in the future, this will be like the image ID, like the image name from like file system when we're working on it with like real images. Okay. So here, I guess we go here and we push into that thing. So we have like image infos is array list of image info. Great. What's the drink of the day? Coffee? Yeah. Coffee. Image path from S3, you mean. File system is not very big data. Yeah, sorry. Big data, we have to use S3. You're right. My bad. So here we just like, I guess we have, why does he think that this is a fucking pointer in vtable? Is he fucking high out of his fucking mind? Hello? Dude, he's out of his fucking mind. That's crazy. So this should be name is maybe an alloc print on who what allocators do we have available to us? Allocators root GUI alloc maybe. Nah. Root arena. And we're gonna be like, this is just the name, right? So it's just like image with image ID here for now. Cool. And then it's the, what was the other fucking thing? Correct bars is maximum of correct bars and correct flip bars. Okay. Cool. Oh, I see why I wanted pointer v table. It's because the first argument is the alloc. I see. How do I like do this bounded here, and then we initialize this thing from buffer? Yeah, this is what I like to do. New zig shit. Trying to get used to it. So this is like, we know how many we have, right? It's the number of bars. Stage 1, or images. Config data batch size, like this of, what is this, image info? Something like this. Okay. Okay. Cool. So now we have this like image infos thing, and we can build UI with this. Like this. So now this guy is taking in, you know, infos. Oopsies. And for now, I think we can kind of like act like these are going to be constant for the lifetime of the application. So let's just kind of like sort these now. And we want to sort them by just by their score, or like number of correct bars, I think. I guess then name or something, so that they're like somewhat in order. So this is like A is an image info, B is an image info, and does it return a Boolean or something? Probably, right? And it's like, if A correct bars is less than B correct bars, return true, and then return std mem, what's the fucking math? Std mem order, probably? There we go. A name, B name, and then we lexicographically sort the rest. There we go. So this is supposed to be like a less than sort, I think. We'll see if it's about. The fuck? Am I high? Oh, I forgot the context. He wants a context as well. It's this. There we go. No, okay. Oh, this is for the alloc print. I did this, like it wrong again. Oopies. Okay, there we go. There we go. So now we can kind of just say, kind of like fuck what we were doing before. Whatever the fuck we were doing, fuck this shit. Actually, maybe we keep doing whatever we were doing just because it's like convenient to not have to change it. But we go for infos. I think we have like layout two. We have like overview layout here. Like this. This guy gets the overview layout as his root thing now. And if we just say like overview layout, push widget, make label. Yeah, what do we want to do? We want like a bar that kind of expands to fill the width of the screen. So I think we want like a layout here. What does our layout support? Like, do we have like a spacer? I guess that's kind of what we want, right? We want something that'll like fill up as much space as possible as the last element in our layout. Surely, right? I guess like maybe just empty? Yeah, I think we have like a null widget. Yeah. Whose size is 0. That's not very helpful. Maybe we don't really have anything that is what I want. I guess it's kind of like a grid, but the grid we want to make it so that clicking on the empty space counts too. I think we can ask a box to fill the available width. Oh, but he doesn't actually expand. He only expands if the child expands. Okay. What about like rect? We have rectangles that will fill the available space. None of this is really what I want. None of this is really what I want. Okay, we'll just start by making it so you have to click the label. That'll just be easier for now. That will be easier for now. Not ideal, but it's fine. So we're gonna make a grid that has, you know, typically around, we know how many things this is. It's like infos len times 2 is how many things are gonna be in here, and we're gonna have 2 columns. One for the label, one for how many things were correct in it. Where is your mouse cursor, bro? How is this possible? I don't really use it that much. Vim, man. Vim. Okay. Column config here. He wants this stuff. Okay. So the first thing is going to be like expanding. Horizontal justify is going to be left, I think. And then vertical justify is going to be center, I think. And then how do you do these like width things again? It's like ratio, maybe fill up, if I remember correctly, fill up as much of the screen as you fucking can. And then this thing has to, I always forget to do like the double squigglies. Okay, there we go. And then the second column is going to be, I guess maybe we say like take up like 0.8 and 0.2 or something, and then justify right, probably. Okay, cool. So then we have like this overview layout, and we're gonna say for each row, push widget of the name. So that's easy. And then on the right side, we have something, oh, sorry, it's a try widget factory, make label name. And then on the other side, I think it's a little trickier. Can we just, for now, do std format alloc print of GUI alloc heap or something? Of this out of 95. Sure. Info.correctBars. And that should give us something that like kind of works. Just take a look. Fuck. Fuck. Unreachable. So he's mad because something is less than and greater than. He doesn't like that. Why? Because if this is less, then it returns. Then this lexicographic thing should only... What does this guy want? Sort func takes a function that returns true if less than, right? So if A is less than B, return true. Otherwise we don't return. Oh. We forgot the case where if A is greater than... Yeah, my bad. If A correct bars is greater than or equal to B correct bars, return false. My bad. Maybe we do... Else if A correct bars... There. I guess it's kind of more like this. That's more correct. Okay. So we do see that a lot of these guys are capped out. This is ugly as fuck. Can we like fucking buffer the left side? Like, why does it look like that? Like, does this guy have like padding information or what? Are we supposed to like put this guy in a box that's like a little smaller? How the fuck have we done this in the past? Like, what the fuck? Yeah, I mean, he's just like fucking cranking out to max width. So what have we done before? Do we like put things in a rectangle or like a stack? Yeah, this doesn't sound like it's just so ugly. It's just so ugly. And it doesn't usually feel like that. What do we do in like our like image editor? Like, surely we have like grids in here somewhere. Make property list. Oh, so these things are in layouts, and these layouts probably have borders by default or something. That's probably it. Hold on. Max perpendicular length. We have cursor reset, which sets offset to 0. And then we have like container size. Huh. I feel like I'm losing my mind. Oh. Item pad. Wait, hold on. No, he does have like offset 0. Does it just always look like this? Like it doesn't, right? There's like a pad here on the corner of the window. How does that pad get there? I wrote this. I should fucking know how this works. We'll go back and look at it again. Make sidebar, surely. So he creates a stack. Ah. The stack he's like creates a box with the stack inside. And then but even that doesn't make sense. This box will fill the width and height. So then he makes a layout. And he just puts shit in the layout. I don't understand. I don't understand. Because there's a fucking... Unless he renders like the sidebar. Unless he renders the sidebar somehow offset. Sidebar, then main viewport. Oh, wait. Okay. So who's like the root of this guy? Drawer, then remaining. This is a right to left. Item pad 0. Then he has like a non-drawer stack. Where he puts sidebar, then main viewport. Could be something there. Hold on. I guess this whole thing, the rectangle is filling though. The rectangle is filling. Make sidebar. So like this rectangle is filling up the entire screen. Which means that like someone's offsetting text from the left. Make object properties. He's just like making some shit. He's just throwing shit in there. Unless make property list. No, all of this is left justified as well. Why does it look like shit? Am I just like out to lunch and it's like it is padded on the left? I just didn't notice. No, I mean that shit's going all the way up to the fucking corner. And definitely this side is. Definitely, right? Dude, I feel like I'm fucking high. It's gotta have something to do with this like sidebar stack shit. It's gotta. Make stack zig. So how does he do his like layouts? He goes like, let me position myself. Okay, so I have like size policy of match siblings and allow expand. And then if it's match siblings, I update this stuff with as much space. I tell them that they have like the fucking world. Dude, I'm losing my mind. I'm actually gonna lose it. I guess we will just ignore this for now and let it look like shit. But I do want to figure out whose job it is to do this, because it really feels like somebody should. Oh, I can't help myself. Okay, function render. In a layout. In a layout, we get child bounds on this guy. Which calls layout bounds rel layout. Layout bounds rel layout. So this gets me a child item iterator. And when we call next, here, Jesus Christ. What is items here? A segmented list of layout item. I see. And then my layout item bounds, I can't help myself. I have to look. Ooh. Padding between elements. No, I mean, all of this is zeroed. Okay. Whatever. Whatever. We ignore it for now. We ignore it for now. Pragmatic solution is writing up space at the beginning of the end. Yeah. I guess, right? I guess. Fine. Label. Throw space here. And here. Hack. Someone isn't padding correctly. And we'll do it on the other guy too. Okay. This will be a task for post-stream me. Because it's annoying, but whatever. All right. Sure. And okay. So come in here. These are sorted kind of shittily, huh? We can fix that by the name text always having whatever it is, like fucking left pad with 3s or something. It's like something like that. Okay, so now are these sorted in like 95s, 3, 4, 6, 7, 8? Yeah, that's better. These need to be in a scroll view, obviously. Obviously. So where the fuck we're building the UI? We have here widget factory make scroll view. All right, there we go. Okay, cool. So now we just have to make it when we click on these things, something happens. So can we go like widget factory make interactable? So we have this label, and we want to have a click action, which is open open image, or like, yeah, inspect image at ID, I think is the play, and then no drag action. So we need this guy to have like a inspect image, and he has a image ID is a U32 probably. And then here, when we create these infos, we have ID is equal to image ID hype, and then here we have ID is equal to 2. Okay. This is mad because is this a fucking U size? Yeah, why is this U size? Because that's a U size. Fine. All right. This guy needs to handle that. So open image. Was it inspect image? And can we just say like stud debug print inspect this one, just as a stopgap. Nothing. Oh, I did it on the right side. Okay, so we just do it on both, I guess, for now. Like this. Boom. Good enough for now. Boop. 0, 60, 45, 34, 28. Cool. Good enough for now. This will work. It's funny how much it looks less like shit if you do this. Set the clear color to the background color from GUI. I think it's in here somewhere. If we're just like, use this shit, please. R G B A. It's funny just like how much of a difference this makes. Right? This looks so much better for some fucking reason. Just because like slightly higher lower contrast. Okay. So now we need to make it so that when we click on that thing, we jump to that view, right? So we have all of the widgets here. We just need to make it so that the root UI, I think we have like a one of thing. How does this work? Make one of. So I guess this guy says, yo, somebody is going to tell me which one of these I'm fucking rendering. And this just comes from self-selected get. What is our like, I see. So there's like a get function on some retriever that we pass in, and then he just only ever renders or does input on that thing. So here we have like, image, like, app view retriever. That's gonna be like, probably he has like display mode is display mode or something, right? And then this is going to be like, I have some options, right? So we're gonna be like, one of these is the overview, right? Does this thing have to be, this takes like a list of things, but this will live on the stack, right? So does he dupe it? Yeah, he does. So we can call it this way. So we have like overview layout, which I guess we kind of want the scroll view. Right, so we have this guy, and then we have like inspection, which is, you know, whatever our old root layout was. Layout here. So it's just layout. For now. Okay. And then we need to make this like app view retriever. And we have like display mode. And this is going to be like, I guess like this. So we're going to be like either in overview or inspection, right? Display mode here is a display mode. And we say like get is going to return a usize. And it's literally just like, return int from enum of display mode. Easy. Right? And then now we just need like display mode here as a display mode, like this. This guy gets him here. And then when we get inspect, we say like display mode is equal to inspection, and displayed image ID is val. Right? Easy. Easy. Display mode, overview. I think that works. And then we use one of here. Where was our get function on app view retriever pub? Close. Dereference pointer. Okay. Nice. And then all we have to do is like throw a back button at the top of that. Wow, that actually went not too bad. We will make that work. So in inspection mode, just at the top, we just throw a like make button, and this button is like back, like overview for now, and it's just like GUI action go overview or something. Fuck it. And then here we're just like go overview is like set display mode to overview. Okay. I think he doesn't like this. I think that there's some trick we have to do here to make this the right type, because I think that this thing like ends up as a enum tag of the GUI action, not the GUI action itself, which is really fucking confusing. Is this the trick? Yeah, I think that's the trick. So now I like go here, click on 0, overview. Oh, baby, look at that. That's slick. And so like the vast majority of these are like pretty correct. And then we go here and, oh, that's not good. That's really bad. So if I click on the one at the top, it's like the mouse is still fucking down when I get there. That's so funny. Make interactable has a problem here where he issues on click down instead of click up. Which is like kind of okay. I guess it's more that the button shouldn't trigger until it has seen us go from clicked to unclicked. Like, he should be seeing the mouse go down this frame. Right, so do we have like some way to check that? Right, so it should be like mouse down inbox. This should be like input state mouse pressed. And this, and I think that fixes it. Yeah, so oh. Oh. So if mouse is down in box, we want to be in the clicked state. Unless, so we need the, if the mouse was pressed and mouse down in box. Here. So we, this is confusing. So it's like if the mouse was clicked, then we enter click state. But now, since mouse wasn't pressed, we enter this, right? So can we do this? We'll say like stay clicked is here. And then we're like, if mouse pressed and stay clicked, then this. Else if not stay clicked, then we're allowed to move into non-state, I think. Okay, so cool. And then I go mouse down, mouse up. Okay, so there's still a problem where it's getting, what the fuck is the difference between mouse down in box and cursor in box? Oh, because mouse down, I see. Mouse down. I actually want this to be mouse pressed in box. And I see. So mouse down in box is that we press the thing in the box. And cursor was in the box, right? And then we want this to be like if mouse down in box and self state is equal to clicked. Here we go. And that we do this. And then before this, we say if mouse down in box and input state mouse pressed, then we enter click state. Then if we're in click state, we can do some stuff. And then I guess it's kind of like this stuff goes here. Then we handle click state down here. So if mouse down in box and we press the mouse, then we enter click state. Else if cursor in box, and then we should be like else if input state mouse released here maybe is how we exit this thing. Let's try that. Let's try that. So click this, release, click, hold, release, click, 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 click. Okay, so that's still a fucking problem. Because here, if mouse released, yeah, because here we have, god damn it. Hold on. Dude, this is so hard. Why is this so hard? So if I click on the box, I go into click state. This should be, maybe we need to be more like a state machine here. Maybe that helps. So if I'm in none state, and, you know, mouse down in box, and we press the mouse this frame, then we move into clicked. Okay. Else if cursor in box, we move to hover state. Okay. Then if we are in click state, it's like if we release the mouse, we move, it depends on like, if we release the mouse and cursor in box, then we're like, yo, we're fucking, we did the shit. We click the button. Else if mouse released, we go to none state. I guess kind of this goes to hovered state then, probably. And then if we are hovered, and if we leave the, well, feels so complicated. This feels like so much more complicated than what I had before, but what I had before didn't work. But this feels like so close to being elegant and correct. You know, it feels so close. So this is what we started with. Mouse was pressed in the box and the cursor in the box. We enter state clicked. The only problem with this is on the first frame of this, the mouse was pressed in the box before the mouse was pressed in the box before we rendered this. Let me double check here. I think that we could maybe consume the mouse press event, and then maybe that solves all of our problems. If in like interactable, if we see emit click, we want to like consume the mouse down event, probably, right? Does that fix it? Aha! No. Why not? I don't think that like the button should not be getting mouse pressed, no? Am I like fucking stupid? Oh, he's looking at mouse down location as well. Does that, if I like consume mouse down location, is null here as well? This is like a fucking multi-frame thing. I guess that's the problem. So even if we consume the mouse press event happened on a previous frame, but we never saw it. That's the problem. So like this should only happen if we saw click state. Which feels like we were close before with like if input state mouse pressed. We really need to be in this widget when we see the fucking mouse start, right? So why didn't this work? Yeah, that's confusing. Why didn't this work? He does get one true and then a bunch of falses. Is it this? If I am clicked and this, then we're chilling. Maybe that's it. There we go. Oh, so now it works first time? Oh, that's funny. So the first time it works, but then every other time we are in clicked state when we leave. Right? So here he has to make sure that he clears his state before generating the action so that next time we're still good. I think that's where I got confused. Ah, I see. There we go. Hype. Okay, this is, we've seen better. We've seen better, but this already is like pretty good, right? So we can go over here and we can see that this guy got 95.95. Here we need a little bit more stats here, I think. Okay. I would love it if this slider also moved through the sorted order. So I would love to see here maybe like how many bars are correct. So we could do something like scanner here shows he shows how many were correct. And that means that we have, hold on, let me think. This displayed image ID, can we change this to be, can we change this to be like info index? Displayed image info. Okay, hear me out. So this guy probably still takes like image infos, displayed image info ID. displayed image info is val, which means this inspect image actually just says the index here. Hold on. Hold on. Okay. Okay, so this guy, we get the value, we look at this thing, and then we update based off the displayed image ID, which is different than the info ID. Okay. Then this is displayed image info here. Displayed image info. Okay. So here we want to have like image ID from info. Info image ID label or something. And he's like, I have my infos here, which is a list of image info sorted. I have my displayed image info here, which is a usize, and then I have some like buffer to write some text into. Okay. Like this. And here he's like, self infos. Wait, this is wrong. This is supposed to return an index, I think. On the dragger. His retriever. I think it returns an integer, a U32. So how does this work? Get val, he calls get val. So here it's like get val returns U32 probably, and it's like self infos displayed image info ID, and then this is confusing, but this is like we're abusing the API here, I'm pretty sure, but that's okay. So now here we say display image ID, info image ID label, and we kind of like populate this with our shit. Okay. This is going to be fucked up because he is going to try. What is happening here? U32 instead is an image ID info label. Must be a U32 or a struct with get val method it returns. Am I fucking high? Probably public here. There we go. Okay. Infos. Like this. Is he happy? Not quite. Items here. Items here. Okay. Okay, so now we need to make it so that when we get the new thing, it's like gonna be like displayed image info equals displayed image info plus image. We have like infos. So this thing's gonna come in as like a number that is like bigger or smaller than the existing displayed thing. It's not like a movement. It's like a new number, right? So you like drag on the thing, it emits numbers. So what's kind of confusing here is that this is gonna be like val is a U32 here, and we have like displaying infos displayed ID. Right? So we want like We want like val offset. We need to like reverse engineer what the offset is and apply it to the info index instead. Like, because we're trying to modify displayed, which is like fucking stupid. This is like hack. Right? Really, the drag API should probably return an offset, but changing that now is going to be like a massive pain in the ass. So I'm not going to bother. And so we're just going to cheat. So we have like val offs i32 is going to be int cast of val, right? And then we're going to be like val offs minus equals int cast of the displayed thing. And then this should give us our offset. And then we say displayed image info plus equals val offs. And then we do like, we need to do some like integer shenanigans. So then we go like int cast stood math clamp 0 displayed image info I from 0 to the batch size config stage 1 config data batch size -1 or something. It's like something like that. Okay, so we're hoping to see, we are at 30, 63, 5, 16. 30, 63, 5, 16. There's a problem here with like, how, yeah, okay, so this is just assuming, this just doesn't work. This just doesn't work, which is fine. Which is fine, we just won't do this. Because it's kind of like expecting the number to like match what it used to be, and that's like fucking everything up. But what we can do, wait, hold on. Wasn't I doing this in the wrong fucking spot? I was. Wait, why the fuck was that doing anything at all? Because this, wait, hold on. This is fucking stupid. Wait, maybe it does work. I just did it in the wrong fucking spot. Let's try this. Wait, hold on. Maybe it does work. No, it doesn't. Okay. Yeah. We'll just replace it with previous next buttons. Fine. Fine. Uh. Previous. Next. Inspect prev. Inspect next. This will do for now. And then instead we will convert this guy into extractor of a label or something. Yeah. Fine. 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 Return like stood format buff print into self buff of image plus the number. Okay, which is like I don't know, man. In self infos itself. Wait, we can just use the name, no? Yeah, we can just return self infos at self displayed image info dot name. Yeah, that's great. Great. Okay. Inspect prev. Uh, inspect prev. Inspect next. So this is just gone, I think. And it's like inspect prev is saturating sub 1. And next is +1. But we clamp this to be the minimum of this and stage 1 config data batch size -1. Okay. Oops. All right. Does that work? Does that work? So I go to 60. We should go 45, 34. These guys are not calling update now. So image updater update with display like image infos. Displayed image info ID. Something like this. Why doesn't he like this? Oh, items. Okay. That better? Click on 28, 34, 45. Yeah, this will do. So this is 30. 30 is the worst. 63, 05. 05 is this. 63 is that. 30 is this. Okay, cool. Cool. This is already quite a bit better. Whoa, what the fuck was that? I don't know how the fuck that happened. Okay. Not ideal, but it's good enough. Okay, so I want to see somewhere. We probably want to sort these things so that we kind of see like the flow here. I guess this is kind of like in the right order. I guess what we're missing here is like kind of when like what do we want to see here is we want to see like which bars were wrong, right? And so we kind of want like that view. What's the order here? This is like full res image, low res extraction example, then like high res of the flipped and unflipped. I guess we should have labels on them. That probably would help. That would probably help. So here we just want to go like here we want like the name to go with this thing. So this is like input. Does this compile? This is mad because he's like, yo, expected this shit. Whoa, 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 whoa. Oh, another const here. Yep, here we go. Okay, here we go. Close. View. This does not want to be const. I'm a liar. And then name, we need to use this thing. So we want to do like image like widget factory make label name. Okay. So now we for each of these go like low res is the low res image. We have extracted here. Extract image. And then we have like flipped. Okay. So now we should have labels on all these things. Input, extracted, flipped. Yeah, okay. And then I guess all we really want to do here is like make it so that we can see like on the extracted view and the flipped view, we want to see like the correct answer and what we got. I guess. Right, so in the same way that in our like training view, we have this little thing here. We just want to like bring this into the same view, I think. So let's go look for that, I guess. Train UI. We have like render bar comparison, bar retrievers. This is all in train UI. Can we kind of pull some of this out? Right, it's like source bar comparison widget. And what's he gonna look like? Right, so like this thing is defined in train UI. This is a bar retriever, which has some bar retrievers. And the widgets must be used somewhere. So we construct like a list of 3 thumbnails that have these bar retrievers kind of attached to them. Okay. So it should be like bar comparison widget. Probably in here, we probably have something that's like all of this stuff. I don't really know where this goes. Make comparison view. And he returns comparison view, maybe? I don't really know yet. This stuff goes in here. So we have this bar retrievers type, I guess, lives here. Maybe this just becomes comparison view. We need bar retriever here as well. Okay. Just hard code that 95 for now. We need GL. Is everything else go? What's text color? This goes up here too. Okay, const stud is import stud. Cool. Okay. So now I guess this guy just needs like the widget as well. So I think this guy needs to be like a generic function now because widgets depend on the actions that they can export. So we kind of have this guy. He returns a type. Ooh, returns a struct like this. This is actually comparison view now. Right? And I guess that's kind of like bar retrievers surely has to be like, are these guys copyable? Oh, they are, because they're just texture handles. Okay. And so this is like root, like widget here is a GUI widget action like this. Okay. So here we have like action here. And we have this like return thing. We have some alloc. Okay. Cool. We create a layout for this thing, I guess. Widget factory make layout, which means here we actually kind of need just like a widget factory, which comes from widget factory action. Okay. Widget factory Alec here. Nice. Okay, and then here we just do like layout push here. And then close. I think this becomes like this. Bang, bang, boom. And then at the end here, we have like return here of just like predicted is predicted. That sounds right. Actual is actual. Comparison is comparison. And we return like widget is layout as widget. And so now in our like train UI, we should be able to replace a bunch of this stuff with like, this is going to be bar comparison via widget or something. What do we call it? Bar comparison widget. Okay, cool. So now this stuff somewhere is like bar comparison widget, comparison view, GUI action here. Bar comparison. And now all of this stuff kind of just becomes like this. Bar comparison is equal to bar comparison widget, make comparison view. With GUI action and widget factory. Pipe. Then all of this goes away. And this is bar comparison view now. Boom, boom. Boom, boom, boom. Okay, we're getting closer now. Okay. Cool. So all of this stuff lives in our other stuff now. Cool. Okay. Bar comparison widget text color, I guess, lives here now. Maybe this stuff is going to move. Almost certainly, right? Yeah, I think that this just moves directly into this guy. Bar comparison view. So where we actually like render the shit out, we just have like function, like whatever the fuck this was, render bar comparison. And this is like our comparison view. And we have like predicted and expected. Cool. Where does a CPU tensor come from? We just copy paste this place all over the place. Sure. We'll kind of see how this feels. I don't know. Okay, so we just fucking update our shit, right? Self. Like this, like this, like this, and then this is just chilling, right? What's he pissed about? I guess this is self. Okay. And then wherever the fuck we were doing this before, here we're just like, if self comparison view. We're like, view, we just pass it around, along. Sure. What's he pissed about now? Like this. This thing has to fail. True. Which means this thing has to write try. True. Then this guy's like, if hello? Oh, widgets maybe? Yeah, there we go. Okay, cool. That seems to work. So if we go to like, if we run this again, does it all still kind of work? No, because we just don't fucking push this shit. Right, layout, push widget, bar, comparison, widget. He does have to be in there, huh? We do have to render the widget if we want the widget. Okay, so that seems to be working now. And we now have this thing that we can like pull out. We need to make sure that we deleted everything we're supposed to from here, but I think we're mostly chilling. Yeah. So now we should be able to like yoinkies this shit into the scanner here, right? So we should be able to be like bar comparison widget is import bar comparison widget. And we should be able to do something with this. Don't know what yet. So somewhere when we build the UI, we're going to make bar comparison widgets before the extracted images, right? So here, we need to slip some stuff in between here. So it means that this loop needs to be turned into a function. Push image view to like layout, which is like a GUI layout GUI action. Okay, and then we have like widget factory here. GUI widget factory action. Okay. Okay, cool. And then we have name like this. And view, which is a TSV image view, probably. Where'd the controller project end up? Well, I thought that I was going to take a 3-day break to work on our food tracker, which has turned into this. So we might not finish it. Input image. Okay. So can we just kind of do this low res image? Extracted here, extracted image, and flipped is flipped image. Right? So now we should be able to like inject our shit in here somehow. So we're gonna have like one comparison view for the extracted, right? So we have like barcode comparison widget, make comparison view here. Who, you know, like this. So this is gonna be like expected comparison. And I guess this is like comparison and flips comparison. And we're gonna do something with this. I don't know what yet. I feel like it's like one of those memes. Never ask a woman her age, never ask a man his salary, never ask for you when he's gonna finish a project. We're in a black hole, time diluted, so 3 days seems right. Hell yeah. Okay, so now we just have to like make it so that when we change images, this stuff gets updated, right? So we should be able to be like, widget factory, like, oh, this like also doesn't really work, huh? That's fine. Okay, so we're gonna manually say extracted here. We are going to push comparison widget here. And then extract image as widget. Seems reasonable. Oh, but he needs to be a box in a box, I think. Yeah. Box image view. Sure. Fine. This returns like a GUI widget. That's kind of why this existed. So this is box image view as view, I guess. And then this returns this. There we go. We're getting somewhere. GUI, widget factory, GUI action. Look at these fucking types, man. Uh-huh. Okay, so now we can go back here and be like, box image view, widget factory, and extract image, bing, bang, boom. And then we're gonna do this twice. Flipped comparison, flipped extracted. All right. What a fucking disaster. What a disaster. But we're getting close. All right. Wrong thing. Was curious. I was also learning microcontroller programming at the time. Bootloader was epically exactly what I needed, so appreciate the help. Oh, no worries. No worries. Okay, cool. So now we kind of have something to look at least. It's not ideal, but we'll get there. So now we just have to make it so that we update these things as necessary. So widgets now needs to get like our comparison views. So like comparison is a var comparison widget, comparison view, GUI action. And we have like flipped comparison here. And then we have to like use these when we update the displayed image, surely. Right? So here we have to be like self widgets comparison, render bar comparison with predicted. So what is predicted? Self, like, what am I fucking looking at? Displayed image ID. So we have extracted here. Index outer of displayed image ID. And I guess it's gonna look something like this, right? So we're gonna be like extract CPU tensor, maybe? I don't know, but yet. Slice. Okay. I don't know what this does yet. But we'll see. So we're gonna be like self math executor slice to CPU deferred, sure. Scratch seems kind of reasonable. Surely we have one of these guys, hype, and then we have tensor, slice. Okay, so I have like this like buff here, deferred. We like wait on this thing. And then it's like deferred val here goes into something like this. And then dims is like our input dims. Seems reasonable to me. Okay. So we have this guy. We have predicted. Bars. Bars, I think, here. Nice. And is that it? Okay, let's try this for a second. We'll deal with the flipped one in a second. What is he pissed about? Comparison is comparison, and flipped comparison is flipped comparison. Okay. Try here, probably. Okay, does this fucking work? Does this fucking work? No. Never fucking works. Why fuck would it? 172. He's pissed because this guy is like not the right shape. Which one? Expected is not the right shape. What the fuck? What is this then? He has num barcodes here. So why would this be wrong? Ah! Why is nothing ever right? 95 and 380 by 380 by 1 is crazy. I'm sorry. Why the fuck is this 380 by 380 by 1? Oh, because of the fucking picture. I see. Predicted bars flipped. I see. My bad. My bad. What the fuck is it then? Predicted codes. Okay. Okay. Is that better? Okay, so that's good. So we can see that these are sometimes okay, sometimes not. Cool. And then we can look at like the flipped ones as well. This is interesting too. This is actually really interesting. The fact that this is so gray is like, I think, quite unexpected. I think. Which is interesting to look at. Okay, so now we just need to do the same thing for predicted codes flipped. And then here we actually need to be a little bit careful, where we have like predicted CPU is this. Oopsies. Oopsies. I want expected CPU, my bad. Right, so we kind of bring these here. And we just kind of go like 0 to expected CPU buff len over 2. We like reverse it. So it's like expected CPU buff I is equal to expected CPU buff len -1 minus I. I think that's how you do a little reversies, right? Right? Right, something like that. Okay. So this one, we've got like bad here, good, sorry. They're just both bad? Wait, hold on. Can we look at one that did good? So image 20, this is supposed to be good. These are both shit. So we did something fucking wrong. Why? Because we need to flip here? So true. So true. So how is this 95 out of 95 if we ain't seeing anything decent? It does look like it has. Did we flip this correctly? So it's kind of like we've got like this chunk here, which is like white, double dark, white, triple dark, white, triple dark, which should be on like the right side if we go up. No, they're just the fucking same. So this fucking reversal just did nothing? Why? Oh, should be fine. Am I stupid? Like, we're doing, oh, predicted expected. Not that that should be a mega big difference, but it's relevant to some extent. Oh, wait, maybe this is, okay. So, actual now, we have kind of, we need to look for something that's like easily identifiable here. Double, double, double. Oh, this is fucking mirrored though. It's annoying. I forgot to swap the other half. I forgot to finish swapping. You do have to swap if you want to swap. Alright. Is this better? So now it does look like this is inverted, right? This is like double white, double black, double white on the left. Double white, double black, double white on the right. But then, just wondering how you have time to do all this computer coding. Well, because I just quit my job and burned through my savings. It's kind of hype. Yeah, why the fuck do these not match? Okay. Oh, wait, maybe, oh, hold on. Okay, we go down to like image 50. So on 50, so I think it's gotta be that the flips thing is not. Okay, so first of all, is our like actual flipped correct, right? We're expecting to see dark, white, dark. I mean, it seems pretty clear to me. That this is wrong, no? Dark, white, dark, light, double, dark. It's like, where the fuck is that light, double, dark? And light, double, dark is over here. Do we have these inverted? What the fuck? It looks like it's upside down from the picture. Right? Am I like fucking high? Right? Like here I have actual dark, light, dark, light, light, dark, dark, light, light. Oh, wait, here. Dark, light, dark, light, light, dark, dark, light, light, dark. Triple light, dark. No, this looks right. What about on this one? Dark, light, dark, light, dark. Bunch of lights, dark. Okay, that is right. So then why is the prediction so fucked up if it thinks it did a good job? It must be that this predicted buffer is wrong. Sorry to hear it. Hope the best of you. No. It's fine. I'm doing it on purpose. I don't want to work. I want to do this. This is more fun. I like having fun. Don't you think coding consumes a lot of time, but for very little return? What do you mean? The return is like the fucking love of the game, baby. Like, it's like fucking, like, it's a fucking sick thing to be able to do. It's like fucking magic, right? Like, you start with like nothing and you just imagine a thing that you want to exist and then it exists after. That's fucking awesome. Like, that's the fucking reward. What do you mean no reward? The reward is that you have this fucking awesome piece of shit that you made after. It's sick. Yeah, it seems like the predicted buffer here is just like fucking wrong. It's gotta be, right? Because here we're seeing that we have good results, and then here it's just like, what? Neither of them look good. Is it like inverted by mistake? No, it just looks like unrelated. Like for this 22, is it always showing the same thing? I think that we've got some extra confusion here, where when we say inspect image, this has to also go there. Okay. Okay. So either our stats are, oh wait, no, this one's right. Hold on. Okay, so image 21 here. He has something where the actual, does it match the picture? Dark, light, dark, light, dark, dark. You're right. So like this is already fucked up, right? Dark, light, dark, double light, double dark. Oh, extracted is based off of the predicted orientation. So sometimes they're just both upside, like we inverted, but we shouldn't. I think that's the answer. Is here we don't know which way was right. So we're just looking for one of them to match expected. So we just don't flip it here, I think, and then one of them will look right. Okay. Is that the answer? Yeah, I see. So like in one of these pictures, the picture will not match the actual bars, and that's okay. Because in the other one it should. Okay, I think that's right. Right, so we have, now we can like look at this, so we can go to the overview here, and we can say like, what do we, like, image 11, was this one good or what? And we can go scroll through this. You can see like at low res, it's like, wow, that was like a really bad box. But despite how bad of a box it was, the network still managed to like perfectly predict it, which is awesome. What we could even do here is we don't have to show both. Right? We can pick which one to show based off of which one succeeded. You know what I mean? But showing them both isn't the end of the world. So maybe we should sort them by like which one did better. But this is still pretty good. Still pretty good. Okay. Cool. And now we can go to the overview and we can say some of these guys did really fucking bad. And it's like, I want to see here also the stat. What are you wrestling with right now? Yeah, we're training neural networks to scan barcodes for us. That's kind of the idea. So we've kind of like built a whole neural network training framework from scratch. And we have like kind of trained it to predict both locations of barcodes in a larger image as well as the bars themselves. And we are trying to kind of work on visualizing like how it's performing. We don't really know, so we're trying to like get there. Can we throw like name here and correct label here? And then we can kind of, wherever the fuck wherever the fuck we do this, we render this guy when we create the image info, like this. And then it's like this, correct bar, like max correct or something is this guy, bang, bang, boom. And then it's easy for us to reuse this text as we can like render this in the UI easily now. Info, correct label, boom. And then we can kind of just shove this somewhere like here. Like this. I guess we kind of need it to be like this. This guy needs to be like image, like info, image, correct label. Boom. And then we just like extract the correct label here instead. Image info, correct label, there we go. Oh, pretty neat. It's kind of like C, right? Yeah, it's a lot like C. Don't know much about machine learning. That's okay. There's not that much to know, to be honest. It's just like, do some math, check how far away your shit was from zero, and see how you can make it go a little closer to zero, and then do that a bunch of times in a row. Okay, cool. So we can look at some of these like 94 ones now. The text is kind of fucked up, but that's okay. And we can be like, okay, so he got one bar wrong, and it was the one here. He predicted light, dark, light when it was supposed to be triple dark. Right? So that's here. He somehow predicted on this bar light, dark, light, or dark, light, dark, which is insane. That's insane behavior, right? So probably, like, this is kind of like exactly what I was worried about. Where I think what's happened is that it's kind of learnt patterns. He's kind of learnt patterns, right? And so he's kind of learnt that, like, in the center, he's expecting to see dark, light, dark, light, dark. And I think what happened here is on this image, he's just like a little bit more confused about where he is. I mean, this image does look kind of fucked up. Like, I can't really place it, but it doesn't look normal. And so he's like, just instead of like doing something reasonable, he's just like, right here, there can't be three darks here. That's crazy talk. And he just fucking slaps the light on there. Right? This is so much different than like the type of bug that we would see if we were parsing it ourselves, right? Because like if you fucking just look at the pixels around you, you're like dark, right? So it's like insane that he would predict light here, like absolutely fucking batshit crazy. So we need to find a way to stop that from happening. But cool. I would say that while this UI kind of sucks fat ass, we at least have like information now. I was hoping that we could like use this to verify on a real set of data today as well. But I don't even know where the time went. We just got kind of like just gooey shit. But I think that spending that time on gooey shit is like worthwhile. Right? Like it's definitely worth, because like this is incredibly useful information. Incredibly. So we'll see. I might try to train something overnight. I might not. I might come back and like do a couple augmentations in happy hour tomorrow and not post, because like the next couple like sets of training experiments I want to do for this thing are not very like, there's not a lot that I want to do here right now. I just kind of want to like flip some bars like randomly flip bars, and then maybe also I think that like the network is probably activating, like we need to fix our resampling here because this is like fucked and like it never fucking trained on this type of work. So we need to either like do the same shitty downsampling that we're doing in here, or we need to fix our downsampling so it doesn't look, or our resampling so it doesn't look so much like shit. Probably both. But yeah, I think those are all like minor improvements. So I might stream it, might not. We'll kind of see. Otherwise, anyways, we'll be back tomorrow with something. I just have to think about what that is. So yeah, thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is 4 o'clock now, so anywhere between 4 or 3.5 hours ago, and now is when you should expect to see us live. If you're watching on Twitch, there's a YouTube link in the Twitch description where, you know, most stuff goes up, or I guess I should say, like, yeah, just over half of everything goes up. Basically, if I think that it is something that is like YouTube algorithm friendly, it goes there. So something that's like 2-hour chunk of something titleable, right? So sometimes we work on other stuff. Like in the happy hour today, 12:30 to 2, we were working on like code cleanup for the Zig 015 upgrade that we did yesterday. So that type of thing, it's like, it's not really worth another video, but like it is worth streaming and doing. So if you want to see that stuff, you either have to catch it live, or the rest of the VODs go up on Patreon, YouTube members, or in Twitch VODs. And if you pay in the appropriate place, you get access to that stuff. And you get access to the knowledge that you are helping the stream survive, because it will end when I run out of money. Anyways, I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.